Hi students, we're here today to look at a concept involving a quadratic where you take standard form and convert it to vertex form using the box method when a equals 1. So let's look at this quadratic. First of all, we notice that this quadratic is in standard form, but we want to convert it to vertex form. So to go about this, first what we'll do is we will put a box around our first two terms of our quadratic. Okay, now let's take that quadratic and model it with a square, because what we want to do is we want to make this quadratic a perfect square. So let's draw our square. It's not a real good square, but it'll do. Okay, now the first thing that we want to do is we want to use this area model to represent our quadratic. So let's take our first term, x squared, and let's put it inside our first box here. Now, x squared. We're using an area model, so we need to know what the length and width of this square would be to determine what x squared would be. That would mean that the length would be an x and the width would be an x, because x times x equals x squared. Now, let's look at our next term. Our next term is an 8x. How would we represent 8x in this square? Well, since this is a square, that means that the length and the width of our square has to be the same. So the number that I put here and the number I put here have to be the same number. So looking at our number 8, if we took 8 and divided it by 2, we would get what? A 4. So that means that the length of this part of our square would have to be a positive 4. And this would also have to be a what? Positive 4. So now we have our perfect square with the length of x plus 4 and the width x plus 4. Now the area of the square here is x times 4, which would give us 4x. The area of this square would be 4 times x, which would give us 4x. And ta-da! We now have our 8x, because a 4x plus a 4x will give us 8x. Now here's the missing piece. To complete this square, what would the area have to be for the missing square? Well, if this length is 4 and this width is 4, 4 times 4 would have to make this a 16. So now we've completed the square for our quadratic. Now, let's take this and complete it and make it our perfect square. So that would mean that we would take the square that we took initially, which was x squared plus 8x, and we would have to add a what? A 16 to it. And then on the outside, remember, we had that minus 10, so if we add a 16, we have to do what? Subtract a 16. Now, by looking at our square, we know that we have x squared plus 8x plus 16, which is inside of this square. And now, looking at our square, we can rewrite this by using its length and width, which is x plus 4 times x plus 4. And now, we can then take these two terms and combine them and get a what? Minus 26. Okay, now that we have an x plus 4 times an x plus 4, we can rewrite that how? X plus 4 squared minus 26. So ta-da! Guess what form we have? We have our vertex form, because recall, vertex form is y equal a x opposite h squared plus k. So that would mean that our vertex of our parabola would be at -4, -26. So I hope this video helps you completing your squares of your quadratics and finding those vertex. So now let's try some problems on our own.